Okay, so for today's lesson, we're going to review the basic trigonometric ratios, the functions sine, cosine, tangent, secant, cosecant, and cotangent. So we'll do a little bit of a review, and this will help us out in future sections where we start really getting into trig. So let's review some of the terminology. So for a right triangle, the longest of the three sides, here called side C, is going to be our hypotenuse. And then our two legs are the other two short sides, A and B. And you can see how they've kind of labeled the angles with a capital letter, and the side opposite that capital letter gets a lowercase letter with the same letter. So here we have angle B and side A, or angle C, which is a right angle, it's 90 degrees, and then side C, which is our hypotenuse. The hypotenuse is always opposite that right angle. If you remember from geometry, the size of the angle has a relationship to the length of the side that's opposite. So the largest angle has the largest side, and then the smallest angle is going to have the smallest side opposite it. Okay, so the trig ratios we've got are sine, cosine, tangent. We usually don't write out cosine and tangent, we shorten them. So here are the abbreviations, sine, cosine, and tangent. And they are ratios. So when we take the sine, for example, of 30 degrees, we get a unitless number, which is the ratio. And in this case it would be 1/2, so this is a unitless number. The mnemonic SOHCAHTOA is very useful in remembering what the ratios are for sine, cosine, and tangent. So sine of theta, in this case theta being this angle here in the triangle, is the opposite side and the hypotenuse. So here the side opposite this angle is here, and the hypotenuse is over there. So that would be the ratio for sine. Now cosine is adjacent and opposite, so here's our adjacent side and the hypotenuse. When we're talking about opposite and adjacent, we're never talking about the hypotenuse. So in this case you might say, well, the hypotenuse is also adjacent to the angle, which is true, but the hypotenuse is reserved. All right, and then tangent is going to be opposite over adjacent. So here again is opposite and adjacent down there. There are three other reciprocal trigonometric functions, which are cosecant, secant, and cotangent. Now, you might be, your first inclination might be that cosecant and cosine are related to each other because they both have cos in them, but that's not the case. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So what that means is then that cosecant of theta is going to be the hypotenuse over the opposite, the reciprocal of what sine was. Secant is the reciprocal of cosine, so it's going to be the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent, so it's going to be the adjacent over the opposite. Now we also have co-functions. So these are relationships between the trig identity, or the trig functions. So in this case, sine gives the same value as cosine, except it's off by 90 degrees. So an example of this would be that sine, like we said above, sine of 30 degrees is equal to 1/2, and what this means by this relationship here is that cosine of 90 degrees minus 30 degrees which is equal to cosine of 60 degrees, will have the same value, and it's also equal to 1/2, and you can confirm that in your calculator. So that's how these co-functions work. They tell you how sine and cosine are related to each other, or tangent and cotangent, that kind of thing. Alright, so let's do some examples. So in this example, it says for us to find the values of sine, cosine, and tangent. In order to do that, we need to know both the sides and the hypotenuse. In this case, we do not know this side, so what we'll do is we'll use Pythagorean's theorem. So remember that Pythagorean's theorem is a squared plus b squared equals c squared, where a, b, and c are the sides opposite their angles. So in this case, this is going to be side A, this will be side C, and this will be side B. So putting the information into Pythagorean's theorem, we'll get a squared plus 18 meters squared equals 33 meters, the quantity squared. And then we can go ahead and use a calculator. We'll solve this a little bit. So we'll get a squared equals 33 meters, the quantity squared, minus 18 meters, the quantity squared. So we get 33 squared minus 18 squared. And then we'll square root that. And we'll get 27.65. And we can round that to 0.66. Now, if we needed to give an exact answer, we could do that. So let me show you what the exact answer would look like. So we got that a squared was equal to 765. And so when we square root both sides, we're going to get the square root of 765, and we can simplify that by looking for squares that 765 might be a factor of. So let's try 4. It doesn't come out evenly, so it's not a factor of 4, 765. Let's try another square. We'll try 9. That does come out. So in this case, we would have the square root of 9 is 3, so we'd have 3 root 85, and we could continue to try to simplify that, but there aren't any squares left. So if we wanted an exact answer, this is what we'd give. If it was okay to approximate, we'd give that. In your homework, you guys are going to want to try to practice giving exact answers. Okay, so now that we know what the hypotenuse is, we're going to list the trig ratios. And they asked for the sine, cosine, and tangent of angle B. So the sine of B is going to be the opposite over the hypotenuse. And so that's going to be B over C. And the cosine of B is going to be the adjacent over the hypotenuse. So that's going to be A over C. And then the tan of B is going to be the opposite over the adjacent. So that's going to be B over A. And so putting this together, B over C is 18 over 33. And those units cancel out. And then we'll have A over C, so that's going to be 3 root 85 over 33. Or we can simplify that to root 85 over 11. And then we're going to have, and this one we can simplify to 6 over 11. And then we'll do tangent, which is B over A. So that's going to be 18 over 3 root 85. And we can simplify this to 6 over root 85. I don't mind you guys leaving radicals in the denominator. It's not a big deal. But if we wanted to put the radical on top, then we'd have 6 root 85 over 85. So either of those two answers would be correct. So there we go. So why don't you guys pause here and try this example. Alright, so given the ratio instead of the angle, we can still find other values of trig functions. So for here, we've got the cosine of theta is equal to 3 over 4. If we draw a triangle real quick, we can get a better idea of what's going on here. So let's call this theta, and that's our right angle here. So you know that cosine is the adjacent over the hypotenuse. So we're going to have 3 and 4 here. And remember that secant, so this is adjacent over hypotenuse. Remember that secant is hypotenuse over adjacent, or the reciprocal, so that means that secant theta is equal to 4 over 3. We can do the same thing here. Secant theta is equal to 1.345. That means that sine of theta is the reciprocal of that. And we can use a calculator if we want, and we would find that that's approximately equal to 0.7435. In this case, it's okay to give a decimal because they gave the value as a decimal to begin with. So why don't you guys go ahead and pause the video and try these problems out, and then you can look in the notes for the answers. Okay, so for our last problem, we'll just try to find all 6 trigonometric ratios for a given angle. So in this case, we're going to do P. Before we can do that, we need to find the hypotenuse. Remember that the hypotenuse is equal to the square of the other two sides, or the square root of the sum of the squares of the other sides. So we're going to get the square root of 10 squared plus 7 squared. And so that's going to end up being the square root of 149. And so now we can put our ratios together. So sine of P is going to be equal to the opposite over the hypotenuse. So that's going to be little p over little m. And so that's going to be 7 over the square root of 149. And cosine of P is going to be the adjacent over the hypotenuse. So that's going to be n over m. And so that's going to be 10 over the square root of 149. And tangent of P is opposite over the adjacent, so that's going to be P over n. Here we've got opposite, adjacent, so that's going to be 7 over 10. And then the other 3 trig values are easy to find. They're just reciprocals. So in this case, cosecant of P is going to be root 149 over 7. The secant of P is going to be root 149 over 10. And the cotangent of P is going to be 10 over 7. So why don't you guys pause the video here and try this problem out on your own. You can look back at the notes. The last thing that we're going to talk about are these special right triangles. So for a 30-60-90 triangle or a 45-45-90 triangle, the ratios, sine, cosine, tangent, cosecant, secant, and cotangent all come out to nice exact numbers. And if you look through this table carefully, you'll see that the numbers repeat themselves over and over again. And there's only a couple of numbers to know. You're going to want to become familiar with this table and how these sorts of special triangles behave. It'll make your life a whole lot easier in the next section when we start talking about the unit circle, which is based on knowing the values of the trig functions at those angles.